The tidal force becomes so intense that it exceeds the binding force between molecules holding your body together as a solid mass. You would be stretched, deformed, and violently torn apart into incredibly horrific and brutal fragments, resembling a stream of fundamental particles smaller than atoms, a cosmic spaghetti. Hello? It's great to see you all again. Everyone loves to travel, but there's a journey that, even if money is offered, not everyone would dare take. That is a one-way trip into the heart of a black hole, accompanied by dark matter, dark energy, the dark region of the moon, and countless other dark entities. It constantly stimulates the curious and adventurous spirit, especially those with brilliantly imaginative minds, like the one watching this video. We've talked a lot about black holes, so today let's explore something different. Rest assured, I promise your brain will stay intact after watching this. Albert Einstein stated that we exist in a four-dimensional space-time, yet if you count, only three spatial dimensions are always present. Off the fourth dimension is time, something you can't quite imagine. Worse than that, the screens of phones, TVs, or computers you're using to watch this video display everything in two-dimensional space, where only length and width exist. However, challenges can be overcome, similar to a sphere being the three-dimensional version of a circle. The peculiar aspect of a black hole in 2D space can be represented as a bottomless pit, somewhere on the edge of which lies a boundary. A circle known as the event horizon. Nothing can escape from within that circle, not even the fastest light in the universe. If an event occurs inside that circle, all information related to that event cannot escape to the outside world. As a result, an observer from the outside cannot determine whether the event has occurred or not. That is why that circle is called the event horizon. Once beyond the event horizon, information about the event will permanently vanish. A wise person once said, "On Earth, people dig endlessly and it becomes a hole. But that is a hole on Earth. A black hole in the universe is created when an enormous amount of matter concentrates in an extremely small volume, the space-time fabric of the universe. Similar to being made of rubber, the mass makes it sink. The larger and denser the mass, the deeper the space-time sinks. And when the density of the material reaches an infinitely positive value, it pulls the space-time of the universe down to infinity and creates a bottomless pit. We are living in a shallow hole created by the mass of the Earth. The curvature of this hole is what makes the moon orbit our planet for billions of years. The speed and distance of the moon from the Earth create a perfect balance, preventing it from falling towards Earth, and also not bouncing out of the hole and rolling away. Similarly, Earth and the other 7 planets in the solar system are also rolling within the mouth of a deeper hole, created by the enormous mass of the Sun. The Sun is extremely heavy. It weighs 333,000 times that of the Earth. And it would obviously dig a massive hole in the universe's floor. But if you think the Sun is heavy, you are mistaken. Giant stars in the universe can weigh 10 to 100 times more than the Sun. A star named BAT 9998 weighs 226 times more than the Sun, or about 75,000 times the mass of the Earth. At the end of their lives, giant stars die, leaving behind black holes with masses 10 to 100 times that of the Sun. The entire mass of a black hole exceeds the imagination of your brain, compressed into a point with a volume of 0, pushing the material density to infinity, to the point where it destroys all the rules of human physics. That is why scientists call it a singularity. And a black hole is just the smallest member of the black hole family. The largest discovered is Phoenix A, with an estimated mass of over 100 billion times the mass of the Sun. Imagine the hole that Phoenix A has dug in the rubbery layer of the universe. In summary, mass deforms space-time, creating holes. When matter approaches these holes, it falls along the curves of space-time. And if it doesn't have enough speed to escape, it will fall towards the bottom of the hole. That's what happened 66,005 years ago, when an asteroid with a diameter over 10 kilometers answered the call of the curvature and fell onto Earth, wiping out the dinosaurs and paving the way for the first ancestors of humans. Now imagine a spaceship hovering near a 2D black hole. Because the material of a black hole has unlimited momentum, it causes an extremely strong distortion of space-time, creating a hole at the event horizon, inclined to the point that once a ship passes it, there is no way to turn back. Even if the captain turns all the speed and launches at the universe's maximum speed. That's why all spacecraft exploring inside a black hole are one-way trips. All advertisements for round-trip black hole travel are scams. Dear friends, please be cautious. Let's return to the journey inside a black hole. If your scaredy cat friend stands from afar to observe, he will be extremely nervous because he won't see you entering. In reality, an observer from the outside will never witness you falling into the black hole because light cannot escape from it. You often hear that time slows down as you approach the speed of light, but that's incorrect. For you, time remains the same regardless of your speed. Only your friend standing far away perceives your time slowing down, a phenomenon known as time dilation at speed. In addition to speed, time is influenced by mass. When near a massive object like a black hole, you perceive time as normal. Your watch ticks away as usual. However, your distant friend sees your spaceship slowing down, freezing at the edge of the event horizon. The event never touches it. Then the spaceship turns red, fades, and disappears from view within a second. What a strange event, you might think. Is your close friend dead? Ha, no, your $5,000 loan is not due. Ha, hi, ho, ho. No, you're not dead. Your spaceship has passed through the event horizon without any fuss, and you're blissfully unaware of it. Though mentioned earlier that you peacefully passed through the event horizon, it only happens when you're brought to a supermassive black hole. As mentioned above, black holes can range from a few to several hundred times the mass of the Sun, and the distance from the event horizon to their core, where the singularity resides, makes a significant difference. To help you visualize, let's go back to the 3D model of a black hole in three-dimensional space. A black hole, in 3D, resembles a spherical shape, and the event horizon that limits the return is the surface of that sphere. A less strict way to imagine a 3D black hole is as a star holding light captive, a prison of light. As mentioned above, black holes can range from a few to several hundred times the mass of the Sun, and the distance from the event horizon to their core, where the singularity resides, makes a significant difference. To help you visualize, let's go back to the 3D model of a black hole in three-dimensional space. A black hole in 3D resembles a spherical shape, and the event horizon that limits the return is the surface of that sphere. A less strict way to imagine a 3D black hole is as a star holding light captive, a prison of light. At this point, the distance from the event horizon to the bottom of a black hole is essentially the radius of the spherical shape. According to calculations, for a black hole with the mass of one Sun, the distance from the center of the singularity to the event horizon is just under 3 kilometers. In contrast, the event horizon of the Phoenix A black hole is 300 kilometers from the gravitational center, 33 times the diameter of the solar system, or twice the distance from the Sun. Gravity is inversely proportional to the square of the distance, making the gravitational field much smaller here, about 15.5 times that of Earth. This means the difference in gravitational force at your head and feet is nearly negligible, even without being inside a spaceship. you would pass through the event horizon of the Phoenix, a black hole, without losing a hair. Well, if you have little money and buy a black hole safari package, your journey will quickly turn into a nightmare. At the event horizon of a stellar black hole, you're only a few kilometers away from the singularity, or perhaps a few dozen kilometers if you're lucky. Here, the gravitational force is so intense that the universe treats you to a cosmic spaghetti meal. Not the type where someone cooks you a bowl of noodles, but where you get torn, stretched, pulled, and compressed into a noodle. For a black hole with a mass of 5 solar masses, the gravitational field at the event horizon from the point of weirdness is about 15 kilometers away, a force 310 billion times that of Earth. To put it into perspective, with an acceleration of 310 billion g, you only need 97.5 microseconds or 0.0295 years to accelerate from 0 to 99% of the speed of light. This super VIP Pro gravitational field will affect you, but in a way you wouldn't want to experience or might not even live long enough to feel. As you are very close to the black hole's center, the gravitational pull on your head and feet will differ by about 1,000 billion times. This means that if you tilt your head forward as you approach the event horizon, the gravitational force of the black hole acting on your head will be over 1,000 billion times stronger than the force pulling on your feet. You will undergo a mechanical transformation known as spaghettification. Specifically, the gravitational force difference creates a terrifying tidal force, so intense that scientists haven't invented terms to describe it. But it's powerful enough to stretch your body into an extremely elongated shape, while simultaneously compressing it perpendicular to the pull. Eventually, the tidal force becomes so intense that it surpasses the binding force between molecules, turning your body into a mass. You will be stretched, deformed, broken, and torn apart in an extremely horrifying and brutal manner, becoming a stream of fundamental particles smaller than atoms, a cosmic spaghetti of the universe. However, if the supermassive black hole you visit is of the non-gluttonous type, you might not even be able to get close to it. Most black holes we observe in nature are surrounded by feasts, which scientists call accretion disks. These disks contain extremely hot matter, mainly consisting of gas, dust, and stars, or planets that naively ventured too close and got shredded. The material on the black hole's banquet table is so hot that it releases intense X-ray radiation, enough to cook you before you even get close to the event horizon. But if you find a truly colossal and purely fasting black hole, you may safely pass through the event horizon. Inside a supermassive black hole, you will witness the grandest show of nature. Being within the intense gravitational field of the black hole. The rest of the universe outside and far from the black hole will fast forward before your eyes. You might even witness stars slowly fading away and galaxies spinning, something you've only seen in movies. However, gravitational lensing effects might distort your movie. It will also turn everything into a bluish tint as light is drawn into the black hole, gaining energy and shifting towards blue light. After entering the black hole, the descendants of your family, offspring, and generations will be born and perish over hundreds of generations, spanning billions of years, all within every second you spend inside the black hole. Due to time dilation from the event horizon to the singularity, the entire time of the universe outside may pass slowly. Gradually, you will see the entire universe, billions of stars and galaxies, condensing into a smaller and smaller spot of light. But you might not live long enough to witness that conclusion. Once you surpass the event horizon, all paths lead to the singularity, where your ultimate fate is to become a subatomic particle spaghetti. There's no engine or spaceship that can take you out. and all your groundbreaking discoveries about black holes will be forever trapped inside. If given the choice, would you be willing to trade your life for the vast mysteries of the universe that you can't share with anyone? Feel free to share your thoughts in the comments below. As always, remember to like, subscribe to the channel, and hit the bell to follow our mind-blowing space content. Now, goodbye and see you again.